this segment is about gravitational waves. Now, you know, I've actually been counting the number of times we mention Albert Einstein's name. And it's disappointingly small. It's like 5 or 6, and most of them were around the cosmological constant. But what might not be well known about Einstein is that his general theory of relativity in 1915 predicted the existence of gravitational waves. For many decades, they remained an interesting conjecture. Probably cosmologists would probably say more than a conjecture. And it really wasn't until, probably the 1960s when serious experimental investigation looking for gravitational waves began. And it became highly controversial. In case you have the impression from today that cosmologists are all happy with each other and get along with each other, a man named Joseph Weber at that time claimed to have discovered gravitational waves, and at an epic meeting at MIT in 1974, he and his major skeptic, Richard Garwin, it is said by eyewitnesses, almost came to blows. We're not expecting that this afternoon. But you know, cosmology is a little bit unpredictable. You never really know. And here's the thing that I'm not going to say much about them except to instill this idea in you. The range of values, the numbers, from the size of the objects that generate gravitational waves to the results that you can measure on Earth is an unbelievable range of values, from stupendously huge to ultra microscopic. And so the challenge is both for the theoreticians at the one end and the technologists at the other is absolutely incredible. And it's already been mentioned. I mean, to say that they are a promising avenue of investigation is maybe understating it. We've already heard today the suggestion that gravitational waves might be able to allow us to mine information from prior to the start of the cosmic background radiation. So, gravitational waves, fabulous subject. Our first speaker is Dr. Luis Lehner.